So let's read a CSV file. And this CSV file has a header, which means each column has a title. So I'm going to say header equals T for true. I'm going to store this in Apple because this file contains tweets and tweet related information regarding Apple. So we run this, and the file I want to use is apple.csv on my desktop. So you can see it has 1000 observations, which means it has 1000 tweets, and also there are 16 columns. So if you want to look at the structure, you can say str apple. So first one is a text column. It's a factor variable. In fact, these are all tweets. And then you have various other columns. For example, whether this tweet is a retweet, true or false. So you have all these information, but we are only interested in the first column, which contains all the tweets. So corpus is a collection of documents. So in this case, each tweet will be treated as a document. We are going to use library TM for text mining. And before we do anything, I'm going to use iconv. So we are interested only in the first column, which is a text column. We also specify 2 equals. And let's store this in Corpus. And now we create a corpus and store within Corpus using capital C corpus vector source. If you want to inspect this, so we do inspect corpus 1 to 5 to inspect first 5 tweets. So you can see the tweets are given here. So now let's do some data cleaning. So we make use of tm_map, and we provide this corpus that we created. And what we want to do first is to make everything lowercase. So we can say to lower, and we'll store this in corpus again. You can check by doing inspect again, and you can see that everything is now lowercase. Next, I'm going to remove all these punctuations like colon or full stop, comma, and so on, and store in corpus. And now if you run this line again, you see all punctuations are gone. Next, I want to remove all the numbers. And again, if you inspect this, you'll notice that all the numbers that we saw earlier are gone, like 4th quarter and so on. Next, I'm going to take out some English words that are so common that they may not be adding much value. And we can specify these words to be stop words in English. And let's store this now in clean set instead of corpus. So if you want to see what exactly is contained in these stop words English, you can run that. And you'll see some of the common words, in fact 171, 72, 73, 74. So there are 174 common English words that can be removed with just one line. And now if you inspect clean set, so let's say first 5 tweets, you'll notice that Apple beat on EPS, earnings per share. So there was a word on, so that is gone. So all those words that are very common, that will be removed. So next I want to get rid of some of the URLs like HTTPS and so on. So let's do that. We'll use remove URL using a function. So we can run this line and then use this to obtain a cleaner set using tm_map clean set content transformer, and we provide this information about remove URL. So now if you inspect this clean set for first 5 tweets, you'll notice that what we had here like HTTPS and so on, so that is gone. Now another thing you may notice is as and when something is removed, so it leaves a white space. So we want to get rid of that too. So for that we say strip white space. Now if you inspect your clean set, you can see the difference. So there was a white space here that is gone. So those extra white spaces are removed. So note that text data like tweets is unstructured data, and to do any further analysis we have to really convert this into a structured data, into rows and columns, and that is achieved by doing term document matrix. So let's store this in TDM. So if you simply run TDM, it gives us some information that there are 1608 terms or words, and we have 1000 documents. So that's number of tweets. So this is a huge matrix, and sparsity is 99%. So 99% of the time you will see zeros in this matrix. So if we convert this into a matrix, so let's have TDM as dot matrix. So if you want to get an idea how it looks, so let's say we want first 10 words and 1 to 20 columns. So you can see AAPL appears in fact in every tweet, because this is a very common word, and in fact these tweets were pulled using $AAPL, so there should not be a surprise that this is present in every tweet. So in fact this is so obvious that we should take it out, because the data was pulled with AAPL, so we should not have that in the tweet, otherwise this will overshadow everything else. But other than that, you can see, for example, out of all the terms or words listed here, only the first one appears in tweet number 20, and first 2 appear in tweet number 19, and so on. But most of the values you can see are zeros. So before I do any further analysis, I want to take out this common word AAPL. And we can specify our own words that we want to take out. So AAPL, I'm also going to put Apple, because all the tweets are about Apple, so we want to get rid of them. So we remove white spaces and create term document matrix again and convert this into a matrix. We can find how often each word appears in this data set by doing row sum of TDM, and let's store this in W. So now if you run W, you'll see that for each word it also gives us frequency. For example, highlighted has appeared 5 times, weakening 8 times. So because we have 1000 tweets and more than 1600 words, we can take a subset and create another W in such a way that, let's say, W is more than or equal to 25. So whenever the frequency is more than 25, only those words are included in W. So if you run W again, so you have less number of words compared to what we had earlier. So with this we can make a bar plot. So we'll say W and let's say LAS equals 2. So all the words will be listed vertically on x-axis, and let's have color. So we can use rainbow. I'm going to put 50. So let's create some room here. So this is the bar plot we get. In fact, these tweets were pulled just before the earnings. So all the discussion about Apple, you can see, is about earnings. So that has the highest frequency. So another thing we can notice is words like this. So stock appears about 100 plus times, and there is another word stock. So that appears about 25 times. So obviously we don't want to have these separately. We should just have one of them, and the frequencies should be combined. So that we can do by going back. So let's have this clean set. So we use this pattern, and we want to say stocks and replacement equals stock. Whenever word stocks appears, so that will be replaced by stock. If you do the other way, that will be a mistake, because if we replace stock by stocks, so what will happen is every time you have stocks, so within that there is a stock, so that will be replaced by stocks. So your word will look like STOCK and SS. So obviously that is wrong. So we should in fact replace stocks with stock. So we do this, remove white spaces, TDM, and create the matrix. And let's recreate the bar plot. So now you'll see there is a single word stock. So stock and stocks do not appear at two different places, and the frequency is now combined. So this is almost 120, 130 plus. So we need a library, WordCloud, and I'm going to create another W here, and let's also sort this as per the frequency of row sums, and we want to sort this in decreasing order. So we can say this is true, and for repeatability let me use a set.seed of, let's say, 2 to 2. So now we can make word cloud. So words equal names in that W that we had, and the frequencies equal W itself. So if you run this, so we'll get a word cloud. So a bigger word means that that was the most frequent. So all the discussions were about earnings. So that's why it is the biggest one, and smaller one indicates the frequency was lower. But we can always play with this. This is too cluttered and we cannot see each and every word. Let's say max.words equal, so let's say we want only 150. So you can see now we have fewer words. Let's also say random.order equals false. Another thing we can specify is minimum frequency. So let's say any word that appears more than 5 times should be included. So if you run that, you get a new word cloud. We can also have colors. So let's say I want 8 and specify dark 2. So you get them colored. Other things we can do is we can change the scale. So let's say the maximum size of the highest frequency word is 7 and the lowest one should be, let's say, 0.3. So you can see it changes the scale. Because earnings is too big, let me make it 5. We can also change rotation percentage. So let's say I want 30% of the words to be rotated. So you can see some of the words are now rotated. If you want more, let's say 70%, you'll have more words rotated. Another library that we use for WordCloud is WordCloud 2. So let me store this data in a data frame where we have names stored in W and the frequency stored in W. We can also give column names for this W to be that the first one is a word and second column is for frequency. So for example, if you do head W, you can see it gives us word and frequency columns. So with this we can make WordCloud 2. So we can specify W, and let's say size is going to be 0.8. We can also specify shape. Default is circle, so I'm going to start with circle. So if you run this, you get this circular word cloud. If you want to change the size to a smaller one, you can do that. If instead of circle you want star, you can say star. Let's also have rotation ratio. So I'm going to say 0.5, so 50%. Minimum size, so let's say I want 1. So you can see now it is in the star shape. You can always play with the size here. Instead of star, if you want triangle, you can make a triangle here. You can also do something called lettercloud. So we specify W and whatever word that you want to use. So let's say this is about apple. So I want to say capital A. Let me also specify size. So we get a letter cloud with A. It could be smaller a too, or it could be apple. So we'll need some packages. So if you have not used them or installed them earlier, you may have to first install them by going to packages and then install. Otherwise you simply run the library. So let's read the file. So we are going to store this in Apple because these are Apple related tweets. And header is true. So this is the file that I have. So let's store within tweets only the text column. I'm just repeating what we had done earlier. So to get sentiment scores, I'm going to use get underscore NRC. So this will call NRC sentiment dictionary. So using that dictionary, we'll be able to provide a score for each and every word for different emotions. So we feed tweets that we have, and let's store these sentiment scores in S. So if you want to do head of this S, so you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different columns, and the sentiments range from anger, anticipation, disgust to negative and positive. So for example, first tweet has a 0 score for everything except positive. So it scores first tweet as positive. If you look at the fourth one, so it has various entries. So let's look at this one. So this is the tweet. So things might get ugly for Apple. So somebody thinks that when Apple reports its earnings, the things may not be good in future. Maybe their iPhone sales and other sales may come down. So this is basically a negative tweet. But if you see here, it has a score of 1 for anger, 2 for disgust, 2 for fear, and so on. So let's check this word ugly. So I'm going to use this get underscore NRC sentiment, and let's see what it thinks of word ugly. So ugly has a score of 1 for disgust, and also negative, it has a score of 1. So you see disgust is 2, so one of them comes from the word ugly. Similarly, negative has a value of 3, and one of them come from the word ugly. So let's see scores for delay. So delay has a score of 1 for anger, 1 for disgust, 1 for fear, 1 for sadness, and 1 for negative. So this is how each and every word contributes to the overall score for every tweet. And when you have thousands of tweets, this tool becomes very handy to do the scoring. So to create a bar plot, what we'll do is for each one of these 10 columns, so we'll do column sums. So for colors, I'm going to use rainbow because there are 10 bars, so I'm just putting 10 here. Let's also give name to y-axis, which is basically count. And let's give a main title. So when we run this, we get this bar plot. And you can see before earnings report by Apple, the highest bar is for negative. So sentiment is negative. So people are thinking that they might miss their estimates. There's also some amount of fear you can see. Joy is on a smaller size. This bar is lower. Now let me get this data again. So I have pulled tweets after the earnings, and it is in my apple2.csv file. Once I open this and run these lines again, I can create this bar plot once again. So this is the sentiment score for Apple tweets, and this is after the earnings report. So you can see now the highest bar is for positive. So because the data was available to the investors and they see that Apple has done really well, so now the sentiment has changed to positive, and negative is much lower compared to the positive one. Earlier, we had a smallest bar for joy, and now it has increased significantly. Similarly, disgust is the lowest one now, very small. So this is how we can compare the sentiment before and after an event.